All right, continuing example 3 from section 3.1 on functions. We're on part D now. We're to find the domain of this function f of x equals 1/2 x plus 7/2. Start with all real numbers. If there is a variable in the denominator, there is not. There are denominators, but they are constants. It's 2. It's not variable. If there is a variable under a radical of even index, there is not. So it's all real numbers. Again, just as we did in B, interval notation, negative infinity to positive infinity, set builder notation, the set of all x, such that x is an element of the real numbers. Okay, in E, start with all real numbers. If there's a variable in the denominator, there is. So we're going to have to exclude from the domain any value for x that makes that denominator 0. And is there a variable under a radical even index? There is. So because we're just interested in the variable expression, recall that we can write this as the square root of 5 over the square root of x minus 3. And we're just interested in that square root of x minus 3 because that's where the variable is. All right, so we know that x minus 3 cannot be 0. And we know that x minus 3 must be what? It has to be positive. And we already said it can't be 0. So we know it can't be 0. In this case, it could have been 0 because it wasn't in the denominator. But now it's in the denominator. Can't be 0, must be positive. So we need x minus 3 to be greater than 0. Then it won't be 0 and it will be positive. Solve this and we get x is greater than 3. So our interval notation says open interval 3 to infinity and set builder the set of all x such that x is greater than 3. Okay? Anything greater than 3 will be fine. If it's 3, we have a problem because then we'll have 5 divided by 0. Notice we didn't have that here, so that's why it could have been 0. So this is kind of a combo problem. You not only have the radical, you have the variable in the denominator. Okay, and then the last one is just another example. Now we have a variable in the numerator and denominator. We also have the radical of even index, right? So start with all real numbers, but immediately we're going to have to exclude some values from our domain. So x minus 2 cannot be 0. And x plus 3 must be positive, but can it be 0? Sure, or 0. It's in the numerator. We can take the square root of 0 in the numerator. That's fine. That's not division by 0. So, in other words, x minus 2 equals 0, x equals 2, so exclude 2, because that will give us a denominator of 0, but also we need x plus 3 to be greater than or equal to 0. It needs to be positive or it could be 0. So x has to be greater than or equal to negative 3. Right? Okay, so what have we found here? Let's think. Go to the number line if you're not sure what to do. You get something that's a little bit a combination like this. We know we've got negative 3 and we've got 2. Okay, we said we can't have 2, so I'm putting an open hole there. Negative 3 we can have, but it has to be everything greater than that. So greater than that, not 2, but then continue on, right? It can't be less than negative 3, but it can be negative 3 up till we get close to 2, but it can't be 2, and then above 2. So here's your interval notation. From negative 3 to 2, open interval, union with 2 to positive infinity. Okay, so if you draw the picture, the interval notation, it just kind of pops right out. And in set builder, it's the set of all x such that x is greater than or equal to -3, comma, x is not equal to 2. See, that describes it. In set builder, we say it's all x's that are described this way. They're greater than or equal to -3, and they're not 2. Okay, this last little tip just tells you if you're working an application problem and you're looking for domain, it has to make sense for the problem. So they're saying, for example, for the area of a circle and you're looking at area equals pi r squared, it wouldn't make sense for your radius to be negative or 0. So you have to consider that when you think of domain.